Alright, sixth graders, today let's take a look at tables and graphs. By the end of this lesson, you'll be able to identify and graph ordered pairs from a table of values. So let's look at a real-life example of this. Tickets for a ride at the county fair cost $2 each. The table and the graph show the total cost of buying different numbers of tickets. So you can see over here, 1 ticket costs 2, 2 costs 4, 3 costs 6, 4 costs 8. So we're going to write the ordered pairs for the graph. If you look, we have 1, 2,
J for dog.
2, 4, and 3, 6 as the ordered pairs. And what do you notice about the relationship between the ordered pairs and the values on the table? Is that the ordered pairs match up with the values that are on our table. So now let's take a look at the table that we have here, and we're going to write the ordered pairs and graph them from the table. Right, so our x values are here, which are always our first coordinate, and our y values are here. So the ordered pairs we're looking at would be 0, 2, 1, 3, and 2, 4. So if you wanted to write those next to, just so you can compare that the table values are the same as the ordered pairs we're going to graph. So we have 0, 2, we have 1, 3, and then 2, 4. Now I want you to take a pair. So why don't you go ahead and pause the video and try this page out on your own and then check to see how you do. So the zookeepers at Como Zoo are buying food for the lion cubs. The table shows the amount of food needed to feed one cub for 3 days. So for 1 day it would be 2.5 pounds, 2 days would be 5 pounds, 3 days would be 7.5 pounds. We want to graph that data. So if you wanted to make the ordered pairs, it would be 1, 2.5, 2, 5, and then 3, 7.5. Now some people get confused when they're graphing, but when we have points in between, but like 2.5, we just are gonna go halfway between 2 and 3, and then we have 2, 5, and then 3 would be 7.5, which on the top of our graph would be 7, so 7.5 would be just a little bit above there. What appears to be the relationship between the number of days and the amount of food is as the days increase, so does the amount of food needed. And then if we also look, if we were going to put these points all together, you kind of notice that they make a line. Right? And why do you think the graph does not show any negative values? Well, we can't have a negative number of days or a negative amount of food, so negative values do not make sense in this problem.